Hello dear students, welcome back to Physics Online Bridge Course classes. So we have been discussing about that fundamental physical quantities and derived physical quantities. So whereas in last class we got that, so how to measure that large distance. So in order to measure the large distance we will use parallax method. So hope you got those informations about that measuring that large distance. So as we already discussed about that fundamental physical quantities, so there are set of 7 fundamental physical quantities are present. By taking use of those 7 fundamental physical quantities, I can express that any other physical quantities, means apart from 7 fundamental physical quantities, all are belongs to derived physical quantities, right? So in case of writing the derived physical quantities, so I want to come to know that, so in that derived physical quantities, how many times those fundamental physical quantities will get repeated here. So for example, so I have to express that speed here. So in order to express that speed, so I will take that, so speed is equal to what? So that is distance by time taken here. So distance by time taken means I can consider, so distance is nothing but length here, time is nothing but t here. So in order to express the distance here, length term is present as well as time term is present. So how many times that length is there? One time length term is there. How many times the time term is there? One time time term is there. For example, let me give another example here. Acceleration is equal to what? Velocity by time taken. Velocity I can write as a displacement by time. In denominator time term is there. So displacement by time square. So look at here. Here displacement is nothing but length here. Length how many times getting repeated here? One time. And here time square is there. So that is t. How many times the time is getting repeated here? Two times. So look at here. So acceleration is derived physical quantity. Is it right? So that derived physical quantity I am expressing by taking use of displacement and time square here. It means that, so in order to express that acceleration, length is repeated by one time and time is repeated by two times here. So like that, I have to consider that all derived physical quantities here. So in case of those derived physical quantities, I want to come to know that how many times those fundamental physical quantities are getting repeated in derived physical quantities, right? So in order to understand such thing, I need to write the dimensional formulas for all physical quantities. So look at here. So I can able to write that dimensional formulas for all such physical quantities. So that is very much important in physics for writing the dimensional formulas. So in case of that physical quantities, so I must able to write the dimensional formulas for all such physical quantities. So the purpose of writing dimensional formula is, if you write the dimensional formula, so from the dimensional formula we may come to know that, so in that a given physical quantity, how many times that fundamental physical quantities are getting carried here. So in order to get that information, I need to write the dimensional formula for all physical quantities. So in today's session, so we will be discussing on writing the dimensional formulas. First I have to understand what is that dimensional formula and how to write those dimensional formulas here. So today's session will be about dimensional formulas. Dimensional formula. So then what is that dimensional formula here? The physical quantities are expressed in terms of fundamental physical quantities. What is the dimensional formula? For example, so we are having derived physical quantities. So those derived physical quantities I want to express in terms of fundamental physical quantities. It means that, so in that given derived physical quantity, how many times that fundamental physical quantities are present. So I have to understand that information. So for that purpose, I need to write the dimensional formula. So today's session, we will be knowing about that dimensional formula. So what's the dimensional formula here? The physical quantity are expressed in terms of the physical quantity are expressed in terms of fundamental physical quantity. The physical quantities are expressed in terms of fundamental physical quantity. So that we can call it as dimensional formula, or in other words I can say that dimensional formula means, so the number of times the physical quantities are getting repeated in the given quantity. So that is also we can call by dimensional formula here. So while writing the dimensional formula, we will use that fundamental physical quantities, means how many times the fundamental physical quantities are getting repeated, I want to know here. So for that purpose, I will make that symbolical representation here. So in that any given physical quantity, if mass term is there, in square bracket, I will write that letter m here. So in that given physical quantity, if length term is there, so I will write that term L here. In that given physical quantity, if time term is there, so I will write it as T here. So mass, length, time. So these three are the fundamental physical quantities in mechanics. So in classical mechanics, so these are all fundamental physical quantities. So let me discuss only about that mechanics here. So mass is represented by the letter m, length is represented by the letter L, and time is represented by the letter T here. So those dimensional formulas I have to express in the form of MLT. So remember here, those fundamental physical quantities are expressed in the form of MLT in square bracket. So mass is repeated by A times, length is repeated by B times, for example, time is repeated by C times. So this is the way to write the dimensional formula. So for example, let me write that dimensional formula for some physical quantities, then you may come to know how to write the dimensional formula. For example, I want to write the dimensional formula for area here. So first of all, in order to write the dimensional formulas, first you know that general formula for those physical quantities, then only you can able to write the dimensional formula. Area, shall I write it as a length into breadth here? So area I can write as length into breadth here. So area I can write it as length into breadth here. So look at here. So area capital A, for example, area is equal to length. So in the given physical quantity, length term is there. If that length term is there, means I will represent by the letter capital L here. So capital L, and breadth term is also there. Breadth means that is also length only, means distance only. That is also I have to represent by the letter L only here. So look at here, dimensional formula for area. So bases are same, powers are added here. So general mathematics here. So L to the power of 1 plus L to the power of 1, L square here. So in order to express that area, is there any mass term? No, there is no mass term. Is there any term? So is there any time term here? So time term is also not there. So I can write that area as, so look at here, m to the power of 0. Why? Because there is no mass term. And L to the power of 2 and T to the power of 0. So this is the way to write the dimensional formula. For example, I can able to write the dimensional formula for volume here. So look at here, I have to write the dimensional formula for volume here. Volume is nothing but what? Length into breadth into height. So this is the generalized formula for volume here. So look at here, in order to write the dimensional formula for volume, what is that symbolical representation of the length? So it will represent by the letter capital L, and breadth is also in terms of distance only, that is also in terms of L, and height is also in terms of L here. So then what's the dimensional formula for volume here? So look at here, bases are same, powers are added here. So L to the power of 1 plus L to the power of 1 plus L to the power of 1. I will take that L to the power of 3. So look at here, in order to express that volume, is there any mass term? So mass term is not there. So if mass term is not there, means what shall I write it here? So m to the power of 0 of course, and L to the power of 3 and T to the power of 0. So this is the way to write the dimensional formulas for those physical quantities. So let me give some other examples here. So I am taking with you small example. Okay. Then write the dimensional formula for density. So density is nothing but what? Mass per unit volume. So I have to write the dimensional formula for density. So density is nothing but mass by volume here. So what's the dimensional formula for density? Mass by volume. So density I will represent by the letter rho here. So mass term is there. So if there is a mass term, means that mass I will represent by m here, capital M. So m to the power of 1. Volume is there. So already I got that volume here. So what's the dimensional formula for volume here? M to the power of 0, L to the power of 3, T to the power of 0. Or mass term and time term is not there. So just you will take that L to the power of 3 here. So did you get my point? So finally I have to express in terms of MLT. So in order to express in the form of MLT, so look at here, m to the power of 1. So denominator L to the power of 3 is there. I will take it into the numerator. So how to take that? All the denominator terms into numerator. If that is L3 is means, so I can take it as numerator, means L to the power of minus 3. L to the power of minus 3. Time term is not there, so that is T to the power of 0. So this is the way to write the dimensional formula. So let me write some other example. So for example, I have to write the dimensional formula for speed here. Speed is equal to what? Distance by time. So hope you are following these things. So distance is nothing but what? So distance is nothing but length only. What is the dimensional formula? Means symbolical representation of the distance. So that is L here. So in denominator T is there. So L to the power of 1 and T to the power of 1. So is there any mass term while expressing that of speed? So no mass term. So if mass term is not there, means so just you will take that m to the power of 0, L to the power of 1. In denominator time term is there. So I will take into the numerator. T to the power of 1 is there. If it comes to numerator, so small mathematical step I will use here. M to the power of 0, L to the power of 1 and T to the power of minus 1. So hope you are understanding these dimensional formulas. So let me write some other physical quantities. So look at here. So then I will write the dimensional formula for acceleration here. So dimensional formula for acceleration. Dimensional formula for acceleration. Acceleration is nothing but what? Velocity by time taken here. So look at here. Acceleration is nothing but what? Velocity by time taken here. So velocity is nothing but what? So velocity is equal to what? Displacement by time here. So displacement by time. In a denominator already time term is there. So shall I write that displacement by time square here? So displacement by time square means, so look at here, I can able to write the dimensional formula for such physical quantities. Displacement means that is nothing but length. So it will represent by the letter L here. L to the power of 1. So time square is there. So time is represented by the letter T here. T square here. Hope you are understanding here. So then, is there any mass term while expressing that acceleration? No. So mass term is 0 and L to the power of 1. So T square I will take it into the numerator. T to the power of minus 2. So this is the dimensional formula for acceleration. I will give one more example. So what's the dimensional formula for force here? So dimensional formula for force means, before I have to write that generalized expression for the force. So from that Newton's second law, force is equal to what? Mass into acceleration. So what's the dimension, means what's the generalized formula? Mass into acceleration. I will write the dimensional formula for this force. So mass term is appear means, so just I will take it as m here, okay, and here acceleration term is there. Acceleration means what? M to the power of 0, L to the power of 1 and T to the power of minus 1. So this is the dimensional formula for acceleration. Acceleration means what? M to the power of 0, L to the power of 1 and t to the power of minus 2 here. So look at here, bases are same, m to the power of 1 is there, m to the power of 0, 1 plus of 0, so that is 1 only, l to the power of 1, t to the power of minus 2. So then what's the dimensional formula for force then? M to the power of 1, L to the power of 1, T to the power of minus 2. So this is the dimensional formula for force here. So hope you are understanding these things. Next I will write that dimensional formula for work done here. So I will give you some assignment if you are interested. So I will post you in the group some physical quantities. So in order to write that physical quantities, means dimensional formulas for physical quantities, you must know about that formula here. So don't bother about the formulas. So just you have to understand, if I give that a formula, you can able to write the dimensional formula for those physical quantities, about the force, about that work, about the density. So we will understand in upcoming topics here. So if that, in case of that writing the dimensional formula, if you know the formula, so from the formula only you can able to write the dimensional formula. For time being, if I give the formula, you must able to write the dimensional formula. So in that way you have to understand this concept. So for example, so if I assign you work for write the dimensional formula for work done, so I will give you, so work is equal to force into displacement. So if I give like this, can you able to write the dimensional formula for this work? I already given that formula for work done here. So work done is equal to force. So what's the dimensional formula for force? Just already I got that, so I will write that directly here. M to the power of 1, L to the power of 1, T to the power of minus 2 here. And displacement is also in terms of length only. Then dimensional formula for work done here, m to the power of 1, so L to the power of 1 plus L to the power of 1, so that is L to the power of 2, and T to the power of minus 2. So this is the way to write the dimensional formula. So just I will give some another kind of dimensional formulas for physical quantities. For example, so in physics we will use the term stress here. So stress. So don't think that it is a general English meaning. So stress means it's nothing but it is a kind of force here. So stress is nothing but force per unit area. So what's that formula for stress here? Stress is nothing but force per unit area here. So I want to write the dimensional formula for this stress here. So force dimensional formula is m to the power of 1, L to the power of 1 and T to the power of minus 2. Then dimensional formula for area, so length into breadth, so that is L square here. So L square means, so dimensional formula for stress here, m to the power of 1, L to the power of 1, T to the power of minus 2. If it goes to numerator, L to the power of minus 2 here. So did you get my point? So write it here. M to the power of 1, bases are same, powers are added here. So L to the power of 1 minus 2, so that is minus 1 here. So L to the power of minus 1 and T to the power of minus 2. So that is the dimensional formula for stress. So don't bother about this equation, you will learn in future topics here. Just if I give this formula, so you may understand, you can able to write the dimensional formulas for this physical quantities. So I will give you another example here. So look at here. So one more physical quantity I need to introduce you, so that is strain here. So we'll write that another physical quantities, so that is strain. So formula, generalized formula for strain is, it is the ratio of change in length divided by original length here. So some physical quantities, so that is strain. So strain dimensional formula I need to write. Change in length means, so that is nothing but L only. Change in length divided by original length, so that is also L only. So these two terms will getting cancelled. So if these two terms getting cancelled out means in this one there is no mass term, length term is also getting cancelled out, so time term is also getting cancelled out. So look at here. So in this physical quantities, mass term is 0, length term is 0 and time term is also 0. So this is dimensionless physical quantities. So in physics some physical quantities are there, so those physical quantities are not having any kind of dimension, so those are dimensionless physical quantities. So if that numerator and denominator terms are same means, so those physical quantities becomes dimensionless physical quantities. Can anybody give another example? So let me give another example. So in last class you derived that means you come to know about that plane angle here. So plane angle means it is the ratio of arc length to the radius of the circle. We said arc length means what? So that is, so length means L only, radius also in terms of L only. These two terms will getting cancel out, m0 L0 t to the power of 0. So this physical quantities belongs to dimensionless physical quantities. So search some more examples for that dimensionless physical quantities. So make one list. So don't search in internet. So just think about that previous classes formulas. So in high school physics in 8th, 9th, 10th standard, whatever the formulas you learnt related to physics, just list out the formulas and check that, means try to write the dimensional formulas. So some physical quantities are dimensionless physical quantities. So try to search some physical quantities having not dimensional formulas. So search for some dimensionless physical quantities. So then you can able to answer for such questions here. So next one. So I will write the dimensional formula for one more physical quantity. So that is Young's modulus. Young's modulus. Again and again I am saying, so don't bother about these formulas. So just I will write the formula. So for time being, believe me, so these all formulas are correct only. Young's modulus is equal to stress by strain. So what's the means what's the formula for Young's modulus here? Stress by strain. So look at here. What's the dimensional formula for stress here? So dimensional formula for stress is, so m to the power of 1, L to the power of 1, t to the power of minus 2. What's the dimensional formula for strain? So strain dimensional formula is 0. Why? Because it is dimensionless physical quantity. I said in physics some physical quantities are there, so those physical quantities are not having dimensional formula. Look at here. M to the power of 1, L to the power of 1, t to the power of 1. So let me introduce one more thing here. So look at here. While writing the dimensional formulas for stress, m to the power of 1, writing the formula for Young's modulus, m to the power of 1 term is there, L to the power of minus 1, there also m to the power of minus 1, here also t to the power of minus 2 term is there. So look at here. Dimensional formula for stress and dimensional formula for strain is same. So it means that in physics some physical quantities are there, so those physical quantities having same dimensional formula. So understand one more thing here. So in physics some physical quantities will carry same dimensional formulas. Can anybody give one more example for this one? For example, speed and velocity will have same dimensional formula. Another set. So speed and velocity having the same dimensional formula, and stress and Young's modulus have the same dimensional formula. Search some more example for these physical quantities. So two physical quantities must have same dimensional formula. So collect such kind of physical quantities. So that is assignment for you people. So hope you will do and post me individually. So in WhatsApp. So I give an example. Some physical quantities having the same dimensional formula. What are those? So speed and velocity, one physical quantity. Stress and Young's modulus having the same means the same dimensional formula. Give some more examples related to these physical quantities. So hope you are understanding about these dimensional formulas here. So in next class we will understand that what are the types of these